Okay folks, so I thought I'd get back to filming some examples, and I'm currently in a classroom hiding where there's no students, but there might be some people walking about, so hopefully there's not too much noise in the background. What we're looking at today is how we solve second order differential equations like this first example I've got. I'm going to run through this. The main point that you need to remember is that when we anti-differentiate, I get the constant of integration appears. When I anti-differentiate twice, that essentially means I'm going to have 2 points where I add a constant of integration, and as a result I'll end up with two unknown arbitrary constants. So let's have a look at what that actually means in terms of this problem. So if I anti-differentiate this problem, let's just zoom in here. If I anti-differentiate the second derivative with respect to x on both sides, then on my left-hand side, I will get back to the original derivative. And on the right-hand side, I'll get x squared plus x, and then I've got to have my constant of integration, c. So I've done my first integral, and this gives me an equation for dy dx. But I actually want to work all the way back to find a general solution. In other words, find out what y equals in terms of x. So I need to anti-differentiate again. So I'm going to anti-differentiate this side with respect to x and anti-differentiate this side with respect to x. And when I do that, I end up with y equals 1/3 x cubed plus 1/2 x squared plus cx plus my constant of integration again. And I can't call it c because it's not the same letter, so I'm going to call it d. So when we work through this, when we anti-differentiate twice, I end up with two constants of integration. One I'm going to call c, one I'm going to call d. And this is what we call the general solution. So if I wanted to find a particular solution now, I would need to know two specific points to find these two unknown values. That's the first video.